Can start now. So, welcome everyone to the fourth event of MLDA Insider. This is me, Nelson, and uh, one of the guest speaker, Yong Shin from Augmentus. We will be talking about how AI impacts the robotic field in industry. So before that, I think we can introduce what is MLDA at Triple E so that you guys can understand what is this organization and how will this impact the whole School of NTU and School of Triple E.
Welcome to the Machine Learning and Data Analytics Lab here at the School of Electrical and Electronics Engineering at Nanyang Technological University of Singapore. My name is Jia Fei. I'm the current president of MLDA at EEE. Here at MLDA at EEE, our vision is to empower our IEM and EEE students to pursue the understanding, application, and deployment of machine learning and data analytics. At MLDA at EEE, our student community consists of four major portfolios ranging from academic and training, career and external, logistics, and publicity. As a club itself, we also offer students a wide range of activities ranging from our machine learning workshops, career sharing sessions, to even machine learning data talks. All with one goal in mind, and that is to provide our students an avenue to learn, research, and apply machine learning and data analytics skills and knowledge to both the industries and academia.
Hi there, I am Liang Yu from Academic and Training Portfolio. We are in charge of teaching material, preparation, and presentation. Aiming to equip our students and alumni with analytical skills, we explore hands-on experience with them and produce lecture videos for the beginners in need. In academic and training portfolio, student committees are more equipped with data science skills and also the communication and presentation of technological content. Teamwork also matters. We try our best to collaborate within and beyond the portfolio to deliver our creativities with their best quality.
Hi, I'm Wilson, and I'm part of the Careers and External Relations team. So we liaise with industry partners for collaborations in the field of machine learning and data analytics. Students will get a chance to have hands-on experience and project management in different projects. These projects will provide students with the relevant skill sets for their future career. Students will also get a chance to participate in talks and workshops by our industry partners. These will provide them with informed decisions about their future career path.
Hi, I'm Andrew from MLDA Academics and Training team. Our objective is to educate and raise awareness on the field of machine learning and data analytics, especially for EEE and IEM students. We curate workshops specifically designed for EEE and IEM students, and we execute those workshops that not only increase the competency on the field of machine learning and data analytics, but also increase the awareness of machine learning and data analytics for EEE and IEM students.
Publicity portfolio at MLDA is responsible for spreading awareness about the club, what we do, our upcoming events, and projects that our members are working on. We're responsible for handling the social media accounts of the club and also designing posters that we put up around the school. It's our responsibility to generate interest among our peers here at the School of Electrical and Electronic Engineering. By being a part of this portfolio, the skills you can gain include design, scientific communication, and social media marketing.
Hey everyone, I'm Kai, and as part of the logistics team, we do two main things. The first being event planning. we think of how we want the event to flow, and then we plan accordingly. And the second being procuring the newest and the coolest technologies so that our projects team can work on the newest and the coolest technologies.
All right, that's from MLDA at Triple E. So I guess we can continue to our guest speaker, Mr. Yong Shin.
Okay. Thank you, Nelson. Would you enable screen sharing for me?
Yeah.
It's the okay. No worries. Take your time there.
Okay. Can you share?
Yep.
Okay.
Okay. Okay, so thank you, Nelson, and MLDA for letting me come to this session and share. So Nelson has shared with me that he has a particular interest in AI and robotics. So I think this session will be very fruitful for him. So a little bit background about myself. So I came from a company called Augmentus. We set up this company with the aim to simplify robotics programming. So we have 3 founders. We have a team of total 10 people now. We are 3 founders, me, myself. A little bit background about myself is that I came from A-Star. I used to lead a team of engineers and developers to develop software for companies like McKinsey, Shell, and hospitals. So and then we have Daryl and Wenfu. Both of them, Wenfu is from still studying at NUS. So he's a student like some of you. And he's actually one of the best programmer that I've ever met. So he used to work with me at A-Star as an intern. Then we discovered his talent, and then we sort of like collaborated together to develop solutions. So as of right now, we are closing a round, and we are actively looking for software developers, full-time, part-time. So if you're interested, after the session, we can have a chat. Okay. So the 3 of us come together to find the simplest and easiest way to program robots. So I think before I dive deeper, this is a sharing session. So any point in time, if you have any question, any input, feel free to voice out and we can have a meaningful discussion together. Okay. So for robotics, right, it's actually one of the fastest growing industry right now with a 26% CAGR. So CAGR means that the year-on-year growth, and it's actually expecting quite rapidly, especially in the COVID era, when people cannot go to work, cannot stand too close to one another. And more companies are looking for ways to actually automate some of the processes that they have. So agriculture is actually a sector that is starting to automate more and more, as you know, because there's a more and more like vertical farming, indoor farming, and a lot of Singapore push towards self-sustainability by 2030, 30% by 2030. Is something that helps to actually a lot of agriculture companies to look for ways to, be more self-sustainable, maintain their manpower by cutting down on, for example, the number of people who they are needed to maintain all the farms. So the current state of robot automation is that right now, the prices of robotic hardware, like robotic arms, have dropped consistently throughout the years. So as compared to, like, for example, 30 years ago, right now the robots, the prices have dropped by around 50%. And if you want to develop robotic automation, the robot hardware is actually cost around 25% of the total budget. And then maintenance around 6%. However, most of the cost for developing a robotic automation system actually stems from the software and the integration side. So which can amount to a lifetime cost of around $230,000. So we all know that robotic engineers now are very high in demand because they need to know software. So partially they are counted as software related career. And we know that fresh grad for software developers, their pay will be anything from 5K to 8K just from the start. And that's why for the software and the integration part for automation, it's actually quite high cost for the robotics industry. So why is it so difficult to program a robot? First, you can make use of robot programming software like Robot Studio, RobotDK, or Visual Component to program robot. However, very often they are quite expensive and they require like a weeks or months of trainings to be able to operate them. Now, for example, like RoboMaster, they can cost anything from 30 to 50K, which is very, very expensive. And then for some of the ERP, you need a lot of, you need to watch a lot of YouTube videos, attend a lot of courses to understand how to exactly to use them. Now, the second part is that different robots have different programming languages. Now, for example, ABB have Rapid, then UR has their own URX programming. Then actually, every individual robot, they make out their own language. And for example, you want today you're programming UR, next you want to program ABB, then you have to relearn the whole programming syntax and everything. And also, sometimes in the manufacturing industry, CAD file is not always available because the customers simply do not want to actually share the CAD file, and therefore sometimes it's very hard. Even you have the ERP, you might not be able to program the robotic software. And lastly, you can program a robot just by jogging through the teach pendant. You can jog for quite a long time. I remember when I did my first robotics project for an aerospace company in Japan. So the project is actually use robot to do automated inspection of an aerospace component. The jogging alone, right, took me 3 months because the jogging robot, even though you can do it on the teach pendant, but to move to XYZ of the robot, right, to move to a 3D point space, XYZ position is very simple. But to adjust the orientation, the A, B, and C, RX, RY, and RZ, that one is the very tedious part. And the programming jogging alone is not very easy. Then if you want to integrate with other systems like TensorFlow, cameras, or you make your own AI algorithm to, for example, optimize the kinematics of the robot. Now, all these integrations are actually quite complex and not that easy to do. I'm not very sure, Nelson, do you have experience with ROS since you are keen on robotics?
So I had intern in A-Star as well for the summer. And
nice.
The title of the intern was PLDC motor control using ROS. Yeah. So I would say ROS is quite important, especially if you want to dive deep into robotics engineer.
Yeah. So I think ROS, since you have experienced ROS is actually a very powerful tool. It's able to integrate a lot of systems together, but nonetheless, it has some learning curve because you need to be quite proficient in C++, CMake, and also you need to open up a lot of command prompts at one time. So that's where we had the idea, the three of us had the idea to come up with a way to simplify robot programming. So our aim is to actually enable non-technical people to develop robotic systems with high speed and accuracy. So this is how our system looks like. So our software runs primarily on apps, on the mobile devices like tablet. And then people can just download from the App Store and then start programming the robot, simulate and then generate the code, and then pass into the robot. So this is how one of our interface look like. So we are able to draw the robot path over component instead of coding. So in ROS, if you want to generate robot path, you need to type in the coordinates of the robot waypoint through the command prompt. And you sort of like need to estimate where should it be. But to make it simple, we make it like a touch, simply touch on the surface or the environment that you generate, that you acquire using the iPad. You touch, then you simply generate a waypoint there. And then you're able to adjust the waypoint accurately in a manner that you want. And then instantaneously, you're able to generate the robot code now, then and there. Then you are able to send it to the robot and the robot will move. So we have the video later on. Yeah, and the last part. Okay. So the last part is actually to simulate the robot path planning. So for example, why do we need to simulate? Because you can simulate whether there's a collision, there's a singularity, whether there's reachability issue of the robot. And then all this will ensure that the robot program that you develop is sound and safe and efficient. So inside our app, we have like interactive simulation environment. We account for collision avoidance. We account for singularity of the robot. Then we also give you the cycle time and then accurate robot teaching. And then lastly is also the Cartesian motion planning. The Cartesian motion planning is a little bit technical, but simply it means that it allows you to do more precise contact movement, for example, welding, polishing, all this robotic movement. So I have a little bit of a video. So what we have here is actually the app that we have. And we actually digitize the whole robot area environment using the iPad itself. And then you simply use the tablet and then you program. So this is similar to, for example, the movie and RVs. You're able to do all the kinematics inside the tablet itself. So we have brought it inside the tablet, and then you're able to generate the robot movement, the waypoints, the simulated singularity, then generate all the codes. Yeah, then you run, then you see everything is all right. Then you simply, with a press of the button, then the robot will move. Yeah, as simple as that. No coding required. It writes the code for you. Okay, then we come back to a more accurate simulation, for example, the welding. Yep. So you can see with just a tablet, you can acquire quite high accuracy robot programming that's suitable. Yeah, and the last part is we also imbue the AI integration inside. So why do we do that? Because we understand painfully that to integrate AI into the robotic system, you need to be very familiar with TensorFlow. You need to be very familiar with like OpenCV. So, and then ROS to bring all of the AI picking application into a robot. So we streamline the whole process and we make it simple such that you are able to train the AI using a tablet and then deploy to the robot. And then you deploy to the camera, then the camera simply will activate the AI and then do the recognition and then do the picking. Now it looks very simple, very simplified now, but I think Nelson will know that actually to do the AI picking is not that simple because you need to account for kinematics, you need to account for grasping and everything. Yeah. So inside our app, we simplify the whole process, then allow people to actually program robot. Even if there's a need for the AI application, they can just use our app to do the whole stack. Oops, sorry. Okay, sorry.
Yes.
Yep, so the applications that we are aiming for is inspection, pick and place, spraying, welding, polishing, and machine tending. So these are the generic use cases of the robotics, and through our app, we can do all of these applications. Okay, so enough sharing about my company. So I'll delve a little bit deeper into the AI and robotics. So the application of AI and robotics is a very, very wide domain. There are so many different use cases, so many applications. And for the sake of the sharing today, we will focus mainly on 3 areas. So how AI is using in the vision aspect of the robotics, and then how AI is being used in the interaction interface aspect of robotics. And then lastly, how AI is being used in the motion planning of the robotic arms. Okay, so for the AI vision in robotics, We know that AI has come a long way. Right now, if some of you, I'm pretty sure most of you in the MLDA club have used AI before. You build your own AI models, and then you deploy your own AI applications. So you should really pretty familiar with how to build AI applications, and painfully aware of some of the limitations of the AI processes and the efficiency and the accuracy and so on. So conventionally in robotics, the vision part has been programmed using the conventional image processing methods like thresholding, like morphology filters, or tuning out the blurring filters, Gaussian filters, and so on. So I spent the first 2 years of my time in ESA doing image processing. And then I understand that for the image processing, like conventional ones, you will chain out a lot of algorithms together to try and filter out and leave the component or the object that you want. Then you base on that, whatever that's left after the image filtering, then you do detection on it. The good thing about AI is that you don't need to go through that process. You simply acquire a lot of images, you bump it in, you do your labeling, then you can do your AI work already. So AI is actually relatively simpler than conventional image processing, and it's very suitable for dynamic environment in the sense that, for example, you want to detect strawberry, like one of our projects that we have. Now, strawberry come in slightly different shape, size, color, and everything. So using the conventional image processing is actually quite hard to detect the strawberry in a reliable manner. And this is where the AI will come into play for the vision of the robot, because you keep training a lot of the robot strawberry images, right? The next time you see a strawberry, then you can recognize and then pick the strawberry. Because no matter the strawberry is like a bit fatter, a bit slimmer, or a bit wider, the AI can pick it up because AI have that flexibility. However, there are some limitations to AI in the vision aspect. Now, the limitation comes in the form whereby when you want to detect very small object, like a resistor on the PCB, it's actually very difficult for AI to do this kind of detection because AI simply is just terrible at picking up small changes in the images. So for AI aspect, it's actually much easier. It's more suitable for AI to be deployed in a very dynamic environment whereby things always change in the shape, size, or dimensions slightly. And I dive a little bit deeper into the AI aspect. Is that even for AI detection, there are different levels. Now, for example, you want to train the AI, the simplest way is just dump all the image in and then let the AI do the training itself. Then you will reach the first level, which is the classification. So you pass the image next time, it'll tell you, yes, there's a cat. No, the cat is not there. And this is very suitable for the inspection kind of application. For example, you want to inspect engine, whether the part is there. So you mount the camera on the arm, and then you go to the side of the engine, and then use the AI to check whether the part of the pipe in the engine is there or not. Then the next level is that if you want to know whether the pipe is in the correct position, then you need to do labeling. So this is whereby the localization come in, whereby you need to label the image, be hundreds or thousands of image. I think right now, if we are using pre-existing models provided by Google, I believe most of us do that. You train on existing model, then you don't need to train you don't need so much data to train your AI. So instead of like thousands or tens of thousands, then you can actually just train using hundreds, less than 100. You can get a pretty good accuracy. So classification plus localization, that means labeling. You can do 2D picking using a 2D camera. Then if you have multiple objects scattered in arbitrary position, then you can do more labeling to do object detection. And then with object detection plus a 3D camera, you can do a 3D picking application. And then lastly, which is one of the more challenging part regarding the AI for robotics is the segmentation. Now the segmentation comes in the form whereby if the object, you need to put it at a very specific orientation like this, right? Then you need to know the poise of the object. Then you need to have now introduce additional algorithms like GPD, general poise detection, to actually estimate the poise. Then the robot will know exactly how to position itself to grip a certain object. So the AI comes in even for AI for robotics, for the vision part, it comes with many different levels. And then it's really based on the applications that you are building. Then you choose the kind of level of AI that you want to build. And as you progress, the difficulty to actually prepare the data and the effort actually increases. For example, classification is very simple. It takes maybe 1 or 2 hours to train the AI to prepare the data. However, when you come to the segmentation, which is the part, it probably can take you 1 day, maybe to a week, depends on the complexity, to prepare the data and then to test the accuracy and the poise, gripping and everything. Okay. Any question from the crowd? Okay. So there's no question, then I'll continue. So right now, if you want to do AI vision in robotics, one of the simplest way currently is that you use ROS, and then you combine with TensorFlow, then OpenCV, then you do the AI vision. Now back then in A-Star, I used to work there for 4 years. I remember there was a guy who did AI detection of zero box using robot. And then once he detects a zero box, he will pick up the zero box. That took him 4 months to do it because I attended a ROS training for 5 days. So this is what you see. You need to open a lot of command prompts. Then you need to CMake a lot of times. You change one line, you CMake, change one line, you CMake. And then, yeah, so it can be a little bit intimidating, especially for people who are new to programming. Coming back to us, Augmentus, sorry, I have to sell company a little bit. So we actually inbuilt the labeling and the integration with the robot, the kinematics, everything within the app itself, so that you can do the labeling within the app, and then the camera on the robot will recognize and then does the kinematic calculation to pick the strawberries. So everything is simplified, no coding, no CMake, no command prompts and everything. Okay, so another area whereby AI is being applied in robotics is something called the interface. In the recent years, there has been a movement, the movement called low code, no code movement, whereby a lot of companies are looking for, and also startups are developing or looking for ways to simplify a lot of the processes that were complex. For example, robotics is one of them. And during my time is that there were a lot of feedback from the industrial players that they are looking for ways to simplify robot programming. Because a lot of the people in the plant, they are operators, they are engineers who are very familiar with aerospace engineering, but may not be so familiar with robotics or programming in general. So they are looking for ways to actually allow all these people, right, who are staff of the company, to able to actually get their hands into automation and then program robots so that they can start to streamline some of the processes within the company itself. So usually if a company can do it themselves, then normally they will try to DIY. So how AI is being used in robotics, there are a few ways. If you know more, feel free to share. First one is speech recognition by NLP. That means you probably tell the robot how exactly to move, how exactly to shift itself. So we know that chatbot has come a long way. Now, for example, if you open up a phone and then you say a word and you pick it up and give you, then you will actually give you suggestions and so on. You can do it on your command, but your phone sometimes can do it without your knowledge as well. Because I remember one time my friend was talking about proposing to his girlfriend, and then he put his phone on the table. Then the phone actually picked up the keywords that he's going to buy a diamond. Then for the next week, all his advertisement were about diamonds and rings and so on. So there are actually effort in this space whereby the vision for them is that the moment you tell the robot, for example, cook pasta, then the robot will actually calculate its own kinematics and the trajectory and calculate its force and everything to cook a pasta. But truth be told, I feel that this is still a little bit early. Using voice recognition to command the robot how exactly to move. This is because the robot movement and the programming itself is actually pretty complex. Now, from the outside, it looks like it's just an arm moving. I mean, I can move my arm, then the robotic arm can just move by itself. But there are so many different considerations when you dive deep into robotics that it simply, the voice alone simply cannot make the robot move nicely. And then there are efforts in the gesture recognition whereby they use a camera and AI to recognize the gesture of the person, the arm movement, and then the robotic arm will try to replicate that movement. Later, I will show a video on that research effort. And then the third is actually all these NLP, gesture recognition, all these points towards the effort to simplify the robot programming so that people don't need to code at all to develop their own robotic solution. So the one on the left is by the OpenAI. So what they did was that they used the VR environment to train, to teach the robot how exactly to move. Now, how they do that is that in the environment, then the person will use the VR, right, to teach the robot how exactly to move using the, the Oculus kind of joystick, and then keep repeating. And then the next time the robot encounters the same situation, then you use the AI that is trained using the virtual environment to know how exactly to pick and do a certain task. Now, this is a very interesting one because normally in our own intuition, right, in our own natural logic, we will feel that, or we teach in real life, then we teach the AI how to move in real life, then it translates into the virtual one, then the virtual teach the robot how to move. But this is doing it in totally opposite, whereby the human is actually teaching in a virtual environment for the robot how to move exactly, and then it translates back into the physical environment. So this is a very good, interesting effort by OpenAI. And then in our home ground in Singapore, we do have efforts into using AI to interface with robot, which I will share. Yeah. So this is by an ASA Institute. What they're doing here is that they're using a camera and then they're recognizing the movement of the human, and then the robot is able to replicate the movement like that. I'm not sure whether, Nelson, this was your intern project at A-Star, but I feel that this is actually one of the very interesting research topic at A-Star, whereby they aim to actually really simplify teach a robot how exactly to move by real-life human demonstration.
Actually, I saw the exact same robot in the A-Star that I was working on, but I didn't use that robot, the arm.
Oh, okay.
Yeah.
Okay, the UI robot.
Yeah.
Okay. Yeah, so you can see that now they're moving towards a trend whereby they really want the robot to be simplified, robot programming to be simplified, that you just reenact the movement. For example, just by cooking in the virtual, the VR, or cooking by demonstration, and then everything is recorded, then you're able to make the robot replicate your movement. Okay. And then the last part is actually using the AI for motion planning. Now, motion planning is actually a very, very deep topic because we take for granted how we command our hand to move. Now, the robotic arm is very similar to our hand, whereby we have like a wrist, the joint, and the forearm, and the elbow. So our own hand is actually like a robotic arm. And we take for granted how easy to move our arm to, for example, grab a card or to grab a phone. Because simply, to move to a specific space in your environment, right, you actually need to control the speed of every of your, all these, how do I say, your bicep, the forearm, the speed which you need to move, and how much the rotation, the joints need to rotate to move to a specific. So there are a lot of mathematics involved and a lot of very high precision real-time control of all these parameters that need to take place in order for your arm to reach out and grab that potato chips while you're watching Netflix. So there are actually a lot of efforts into like teaching the robot to move on its own using AI. Now, it might be set up a scenario whereby, one day, what if the robot is able to move on its own, then it takes over the world, able to hold a gun or something. But it's still a little bit far for the whole robot to be fully autonomous, perhaps in the next 20, 30 years. But in the short run, this is actually a very active development area, whereby telling the robot how exactly to move and then able to generate its own trajectory and move is something that the industry are often look out for. And some of the consideration when you want the robot to move on its own, right, using AI, is that you need to check for singularity, reachability, and then do collision avoidance while calculating is all the joint angles and the speed and the acceleration and everything. And therefore, being so many considerations in place, AI for motion planning is actually quite a complex and deep area. So first off, you have Boston Dynamic. I'm pretty sure a lot of us are very familiar with Boston Dynamic. So you see here, they have a robot that is able to, based on AI that you accumulate over the years, that you keep, make the robot jump and jump and jump, then you accumulate all the data. And then you translate into the robot movement. That means the kinematics, the motion planning of the robot, so that it's able to do backflip better than me because I can't do backflip. Okay. Then you have see another effort by Google, which is also using AI for robotics on the right, whereby they have rows and rows of robotic arm, right, that keep doing the same thing over and over, the picking of different objects. And then they accumulate all this data and feed it into the AI, with the aim that one day, you don't need to teach your robot how exactly to move. You don't need to program a robot. You just need to have a camera on one robot, and the robot will know exactly how to move. So you don't even need to train the AI yourself. The AI just need to look and then able to recognize and then find the best possible way to pick up different objects without you ever needing to program or teach the AI. Okay, so coming back with the AI for motion planning. So inside our app, which is quite a unique feature. Now, when you program a robot to avoid collisions in the environment, you need to teach quite a lot of intermediate points. So inside our app, to simplify the process, we actually allow you, we have an algorithm that allows you to actually predict the movement to avoid all the collision, singularity, reachability. Then you will actually predict the best path for you to move on one point to the other. So can you imagine that when you program a robot, you simply need to teach, for example, the major waypoints, and then you will predict the path for you. And then you don't need to actually, jog the robot or teach the robot like 20, 30 points. Simply 2-3 points, you can actually make a pick and place or any kind of robotic application that you want to build. Okay, so I come to the end of my sharing. Then at the end of the day, when we set up this company, we want to actually make it 10 times faster for people to develop robot through mobile devices, through AI, so that we streamline the whole process and condense it into tablets, so that you don't need to buy a very expensive PC, you don't need to set up ROS, then everything can be just through the mobile device. And I think last week before I end my sharing, we are closing our round. So we are actively looking for software developers who are interested to join us and then to develop the solution even further. So if you're interested, feel free to drop me a call, LinkedIn, WhatsApp, whatever, then we can have a further discussion. Okay, so thank you for your time. If there's any question, we can feel free to voice it out, then we can have a discussion here. Okay, Nelson?
Okay, thank you, Mr. Yong Shin, for sharing. So, may I start with some of question that I saw from your presentation just now?
Yeah.
Okay, so from what I see, there are three main aspects of machine learning algorithms that can be implemented in robotics, such as vision, interactiveness, and the last one is motion planning. So I'm currently studying in terms of control system as well as AI in triple E. So would you see like the control system itself is being learned by the robots rather than being programmed? Because currently, like most of the inverse kinematics or even the normal kinematics, we already set some parameters like the control parameters for the robot so that the robot can actually move. Do you see like will the robot move on its own without being teach all these control parameters? Thank you.
Okay. It's a very interesting question. I think the day whereby I fear is that robot move on its own. But based on my own opinion, I feel that it's still a little bit further away. Because at the end of the day, the robot is like a tool. No, the robotic arm is like a tool. It's similar to, for example, a hammer. Just that the robotic arm is a little bit more complex because he has 6 motors and everything as a gripper. So for it to be able to move on its own, I think Boston Dynamics, Google, that's how I saw. They have active research into it. I think there are a lot of research in the US whereby one of the things they have a whole institution looking into automated two-path generation and automated movement of robot. And I have a feeling that perhaps within the next 10, 20 years, we will come to a situation whereby the robot will be so autonomous that he's able to actually just give the task and look at the environment, then he's able to know how exactly to move. So, but I think in the short term, it is still a little bit far away because there are still some limitations that needs to be overcome. Like how do you have the AI, the database so wide that it can, like no matter what situation you throw at it, then it's able to react. Because in the robotic applications, one of the things that often raised, the question that often raised, and the thing that we look out for is safety. Yeah. So, okay, for example, the AI can tell object how to move. How do you ensure a safety during its movement that it doesn't hit the other machinery, it doesn't hit a human? So I think that is something that needs more work to be done, and I think really perhaps within the next 10 20 years, but not in the short term.
Okay, so I think we can give some questions we can give some opportunities for the participants to give some question. So let me share my PowerPoint slides. Yeah. Okay. Okay, so you guys can join the Slido and send some question and I will address it on the Zoom meeting. Oops. Yeah. Okay, so far I don't think there's any question. Let me know if I'm wrong. So, yeah. Yeah, so if there's no question, I will ask another question if that's fine with you.
Okay, sure.
Okay, so um, from let me think. So in terms of motion planning and path planning, do you think um, the normal approach like gradient descent, let me think the name of the approach. Probability roadmap, rapid searching trees, rapid randomly searching trees, and all these type of algorithms of path planning. Do you think it is still relevant, or would you say like reinforcement learning would be more relevant towards the future when in terms of, let's say, motion planning or path planning?
You mean the PRM, RRT,
PRM, RRT, yeah.
all these? Okay. So I think for these motion planners, right, they have been around for quite a long while.
Yes.
And then um, if you're talking, I think most of the times the consideration for them is the speed. I know that PRM is slower than RRT.
Yes.
And yeah, so some of the times during the planning stage, whereby you want to choose the correct kinematics for the robot, then it depends on what you want to do. For example, if you want speed, then probably RRT is better. Then if you want
Yes.
accuracy, then PRM would be a more favorable choice. Then coming back to the question about AI reinforced learning to replace or enhance PRM or RT. This one, I'm not sure about this because I haven't delved deep into this topic yet. But I say as long as the reinforced learning or the AI can help to increase the accuracy or the speed of this kinematics calculation, then perhaps they can be adopted. But I'm not, maybe you can share with us, like maybe is there a recent development of using AI for kinematics calculation?
Sorry?
Maybe yeah, if you came across like a recent development of using AI for kinematics, maybe you can share a little bit more context, then we can have a discussion.
From what I understand, currently there has been some research done to use reinforcement learning for motion planning in simulated like RFIS navigation stack to do this. But I'm not quite sure whether this algorithm will finally replace the old algorithm like PRM or RRT. But for me, that's why I was asking this question, because I feel like it's quite an interesting topic since currently reinforcement learning is currently doing kind of the similar things as motion planning or path planning.
Okay. If there's a reinforced learning that is better than RT or PIM, then you certainly need to drop me a call. Yeah, you need to share with me on LinkedIn or something. Because I think the good thing about this RT and PIM is that it has been tried and tested by thousands of robotics developers. You know, it's open source. There's been a lot of people put their brain power to develop this. So I think if one day there's a better one that comes up, then we will definitely explore that on our end as well.
So
But I just feel that maybe it's still in the research phase and not yet maybe in the implementation phase.
yeah, I think so. Because when I was doing my intern in A-Star, there was one of my colleague doing the path planning, and he said instead of using the normal algorithm, he's currently using reinforcement learning to do some path planning. So that was quite interesting for me.
Okay. I mean, if the reinforced learning can result in like maybe easier to make a robot do complex movement, like like bipedal robot able to navigate through a very complex environment. I think that's something that worth researching into. Yeah.
And for Augmentus, would you say that it is able to do all this path planning? We can choose which algorithm we want to use, or is it that flexible, or would you say that it has some pre-default algorithm that it will be used for the path planning or motion planning?
think for us right now, right, during our early days, we actually let the user choose between two motion planning. But
Okay.
as we develop further, then realize that actually the a lot of the users don't really know much about planners.
Uh,
Yeah. So what we do is that we actually blend the two planners together. So based on the situations and the, for example, some of the criteria, we will choose one planner over the other. Yeah. So
okay.
yeah, because some situation calls for one planner, some situation is more suitable for other planners. We have this kind of mechanism to plan. But as of right now, we don't open the options to the user.
Okay. There are some interesting questions from the
Mm.
participants. So the first one would be, what's the best operating system for AI and machine learning? Would you advise Mac operating system, Windows, or Linux?
Um, well, TensorFlow can run on all these systems. So I think as long as you can build the application that you want, it doesn't really matter what OS that you do. If you want to actually deploy into NVIDIA chips, then most probably you need to do it in Linux, like the embedded system, you need to do it in Linux. Then if you want to actually do, for example, try and error, do your own project, then you happen to have a Mac, then you can use the Mac. However, if you want to, for example, do it for industries, like for example, a manufacturing plant, then Windows is the common OS that they use. So it might be preferable to develop Windows based. Yeah, but uh, Mac would be more suitable for your own project and your own learning, I would say. Yeah.
Would you say that Linux is the, I would say, one of the best choice because of
Mm.
ROS is only available for Linux or Ubuntu system?
Yes. As of right now, yes. ROS 2 is moving into Windows.
Windows, yeah.
Yeah, so ROS 2 has like procession packages and everything that's inbuilt inside. So in the long run, Windows has a lot of potential given that ROS 2 is undergoing rapid development and then it's coming out in the future. So I would say if you want to do real stuff, either Windows or Linux. If you're doing it for hobby and you happen to have a Mac, then use a Mac. Yeah.
Another question from, okay. Another question is, how can you ensure that your codeless robot programming application is bug-free?
Mm.
Is it possible to integrate code with it?
Okay, good question. So as with any applications, if you do software development, then you'll know that there's no such thing as a bug-free. Even WhatsApp, Windows, sometimes they have bug. So what we do to eliminate bug is that we constantly do testing with the end users. So when they test and then they find that something is wrong, they give us feedback, and then we will actually make changes upon it. One thing that we have, I think, very good for detecting bugs near to deployment is test flight. So Apple had this thing called a test flight that enables you to deploy in a small beta group, right? And then the people in the beta group, they will test the software and then they'll look for bugs. So wherever there's a bug being detected, test flight has the internal mechanism to allow them to report to you the bug. And then from there, you can collect the chain of the log of bugs. And then you make changes upon it. Because even if you have like thousands of software developers at Google or Microsoft, sometimes bugs do happen because uh, nothing, we are human, nothing we make is perfect. Uh, One thing I need to point out is that, for example, especially in this area whereby we do very due diligence to ensure that the software developed, the code that we generate, really accounts for collisions. So we place a lot of emphasis on that. For example, it doesn't crash into the environment. It doesn't flip like the robotic arm, right? Sometimes when you reach singularity, it will do like this, it will flip. So we have tested that very rigorously such that when the robot moves, it does not do unexpected turn and hit somebody. Yeah, so we place a lot of emphasis to like a lot of internal mechanism really check for all these flips. Okay. Is there a second part to that question?
I think you answered both just now.
Okay, can.
Okay.
I think the second part is about the coding
The
part.
coding part, yeah.
We
The
generate
integrate.
code, then are we
Yeah.
able to change? As of right now, the code generated is actually as it is. So for example, if you want to make changes to the code, you can simply download the code. Then you copy it and then you can make changes to it on your own. Because some of us may be very proficient in robot programming or coding, then you can make your own customization. And in this case, this Augmentus app is very good in helping you to generate very complex, collision-free, and smooth path. And then you base on this complex path, then you can make your own modification, add-ons, and so on. Okay. Is there any other question?
Yeah. There's no question yet. So for participants who just came in, you can join the Slido link with the event code of 55006. So if you guys want to put some question, you can put it there, or you can chat me directly. That would be fine for me as well. So since there's no question yet, I may want to ask another question if you are okay. Okay. So another question that I would like to ask is regarding computer vision. So computer vision has just been like quite, I would say it's been a new topic again since the development of deep learning in 2013 of the ImageNet, right? So back then it kind of went into like there's not really much development until 2013. So now with a lot of ImageNet, with a lot of data and a lot of new computer vision architecture, right, we have been able to do this kind of deep learning or machine learning models, like what you mentioned earlier, where you can detect strawberries and other types of object. So would you say that computer vision will be one of the main sensors for all types of robotics, or there other types of sensors such as, let's say, LiDAR, that has been used for a lot of autonomous robotics, is still better vision, better sensor than camera vision?
Okay. I would say it depends on the application regarding the sensor part. For the robot to be dynamic, it definitely has to have a camera vision. Like for example, the robotic arm needs to sense the environment, like what to pick and so on. Then it needs to have a camera vision. Regarding the LiDAR part, I think LiDAR is an integral part of the autonomous vehicle. I mean, because it can acquire like that information, the 3D mapping and so on. Regarding other type of sensors that is actually important for robotics is that I think it really depends on the application. For example, you are doing polishing or sanding application, then normally you do not need camera vision, but probably you need a force sensors to actually have a force feedback on how much force you are applying to the surface of the object. So it really depends on the kind of applications that you are trying to build. Yeah. Then you deploy different kind of sensors.
Okay, thank you. There's another question. In your opinion, which online learning platform is the best in learning machine learning and data analytics? Can you suggest us the best source or way in learning machine learning and data analytics?
Okay, this is a cool question. So the best way, I have been learning software for the past many years, even until today. Yeah. So the best way is don't read the manual and just do. Yeah, so because the moment you get hands-on, then you actually then you discover the difficulties and the limitations, and then you will do a lot of Googling and everything to solve all these problems. Then along the way, all these learnings will etch into your mind. If we just keep reading tutorials and everything, even doing tutorial like Python tutorials, which I did during my beginning days, after I finish a tutorial, everything will just evaporate. Yeah, so it doesn't stay in the mind. But the moment you keep on trying to develop something, for example, like AI to develop whether somebody is wearing mask, and then you try to do it, maybe you spend like maybe 1 month or 2 months doing that. But at the end of it, when you develop something and you have the sense of accomplishment that you develop something, then that will stay on with you. Whatever you learn will stay on with you. Yeah. So I think getting hands-on is the best way to learn.
Okay, so I guess the answer would be the online platform is Google. I
Yes,
guess.
Google is the software developer's best friend.
Okay, there's another question. This one is quite interesting. So there are three different algorithms, which is computer vision, natural language processing, and reinforcement learning. So out of these three different learning types of machine learning, which one or which type of machine learning, in your opinion, is the more applicable in the current industry? So out of these three, computer vision, natural language processing, or reinforcement learning?
It's a very interesting question. I would say computer vision has its role for the past many decades, like the standard image processing methodologies. So I would say that perhaps half of the machine vision applications are built on the conventional image processing. But we do see that, just now Nelson had mentioned that since 2013, with the emergence of ImageNet and so on, then there's a bloom in the AI development, especially with the exponential growth of the NVIDIA GPU and so on. So there's a bloom, it's getting cheaper, it's getting more powerful. Then that's why AI getting more and more affordable and getting easier to develop. And we start to see that AI is being used more and more in the industrial setting to solve issues that could not be solved before. Like for example, agriculture, which the produce they can change in size, shape, and color, and so on. Which I would say for conventional image computer vision, it will be harder to solve. Now, if you talk about NLP, which is natural language processing, that one would be more pertaining to the service or the retail sector. For example, in the some of the shopping malls I know in the US, then they will have robot that roams around. Then they will ask you, are you looking for something, and so on. And then ALP as an AI component is very applicable in the retail and service industry because it can understand people and then respond. And then some hotels in China even have all these robots that roam around, deliver food, and then will ask you questions, how are you doing, and response to your inquiries. The last one is reinforced learning. Reinforced learning. Actually, I don't have much experience with reinforced learning other than using the existing neural networks that has been proven. So I can't really comment much on reinforced learning as of now. Okay, Nelson, you have any input?
Okay, not for now, I guess. There's another question.
Okay.
This one is quite open-ended, I think. So, what are your visions for robotics in the future?
Okay, for me, my vision is to like even for SMEs to have robotics in their company, they help to offload some of the repetitive tasks. Now, robotics is not so common in SME right now. There are a few reasons. First one is that the cost. But Singapore has grants to enable the companies, SMEs to acquire robots for maybe less than 10K, they can acquire a pretty good robot. However, the hurdle is actually the software side, just as we mentioned earlier, is that how can the SME hire a developer to develop the software application? Then if you were to outsource the whole thing to SI, then it will be a substantial cost that cannot be subsidized from the grant itself. So what we envision is that next time companies want to have a repetitive task, then they are shortage of manpower, they can just buy a robotic arm and then program it themselves. Then if their production changes or company process change, they can reprogram the robot easily. So if we reprogramming a robot, that skill set becomes as common as us knowing how to actually design PowerPoint or know how to use Excel. So it becomes such a common thing that automation skills and robot programming skills become democratized. It become like asking a person whether he can actually use like Microsoft packages and something like that. Okay.
So as of now, there's not yet another question. So maybe I can ask you for another question.
Yep.
Would it be okay?
Yeah, sure.
Okay. So my question is, so there are a lot of robotic toys, I would say, like Lego, and currently with the emergence of RoboMaster with TGI, yeah. So there have been a lot of, I would say, platform that's like kindergarten or primary school students to learn robotics and programming, and especially with the amount of improvement in machine learning. Would you say that in the future, like primary school would have like some knowledge of programming and I guess machine learning? And which platform do you think is the best way for this type of students to learn?
Okay. I think currently right now the MOE is changing in the sense that a lot of the schools are picking up programming, like secondary schools. I'm not sure, but I heard they make it compulsory for the younger children to learn programming. Yeah. So even in the job market right now, programming is become more and more important when they look for candidates. And I feel that yes, there are a lot of investments by the schools, by the government, by the parents into grooming the child to be a software developer in the future, and hopefully one day go to Silicon Valley and something like that. So to share a little bit about my recent experience is that one of my friend actually came and talked to me. He was from oil and gas industry. So he was quite a senior executive. And one day he came and talked to me and said, hey, Yong Shin, actually I want to become, do a technology startup. And then I want to be as successful as, for example, the founders of like Carousel or founders of like big tech companies. Then he said that he's picking up Python through all these online learning courses, online platform like Udemy and so on. So then I told him that, okay, you want to do a tech startup, then you are learning programming now, but he's 30 plus. Then I told him, actually, you don't need to learn anymore. Stop learning about programming. Because we need to kind of acknowledge that everybody have their own strength and weaknesses with your own niche. So you can be very good at marketing, you can be very good at sales, you can be very good at, for example, critical thinking, but you may not need to actually learn that much into programming to be successful, you see. So one very simplest way is that if you have a very good idea, you find somebody who is very good in programming, then you settle the other things that is outside programming. Then you form a good team. Because normally very good software developers, they don't want to care anything else other than programming. Yeah. So I think it's quite important that we recognize who we are, then what's our interest, what's our goal, then we play along to that strength. And I had coached, I think, more than 10 interns before in my career. And then what I realized was that programming is not for everyone. It's a skill that needs to come with a certain temperament. It needs to come with a certain attitude. It's like cooking, you see. Not everyone is born to be cooks. So I can't cook. I can't even cook Maggi mee properly. Yeah. So I think it's a good effort that there's a general direction to equip everyone with digital skills. But I think individually, we must recognize that it's good to possess some understanding of programming, but to really be really good at it, it really takes a long time and a certain aptitude for it to be really good at it. Yeah, so not everyone should be programmers. I really think that if you have a certain talent, a certain interest, go for it. Be it not other things like cooking. Or my wife loves cooking, so I respect her for that. Yeah.
Yeah. Same for me. I could
Oh, you
only
like-
cook Maggie.
Yeah, oh, man, same.
Okay. Okay. There's no question yet.
Maybe I have a small question.
Okay. Sure, Adrian.
Okay, so maybe from what I understand, you were studying at NTU, right?
Oh, yes.
Yeah. Maybe you can share like how you came across like programming and AI, like essentially your own story lah, from graduating from NTU to maybe this point of time.
Okay. Adrian, are you NTU student now?
Yeah, I'm NTU student.
Okay. Yeah. So I was an NTU student once. Then my journey was like this. After I graduated as a bioengineer from SCBE, I couldn't find any job related to bioengineering. The sad truth was that after the economic crisis, the last one, not the current one, the bio industry in Singapore sort of like it wasn't there anymore. So before I entered NTU, it was booming. That's why they set up biopolice and so on. Then after I graduated, it wasn't there. Then I couldn't find a job. So I leveraged on the only skill that I know, which was LabVIEW. So I only knew LabVIEW back then. So then any job that I find LabVIEW, then I just went and interview for it. No matter the starting pay, like it didn't really pay well. The pay was very low, but I just went for it because I just feel that if I have this interest and skill set in LabVIEW, then I should, build upon it. Then after 2 years doing LabVIEW in the company, then it dawned on me that LabVIEW simply wasn't very scalable. Yeah, I mean, I can build very robust engineering system, but that's it. So I couldn't build anything else. So I found another job at A-Star. That position needed me to do LabVIEW. So it was good. It was an opportunity. Then I went in. Then I also took that opportunity to learn about other programming languages like C#, Python. Then the time at A-Star actually opened my eyes like a lot. So it exposed me to a lot of the industries like aerospace, healthcare, and oil and gas, consultancy, and McKinsey and so on. So suddenly my horizon of open. Then I started to do more and more and get deeper into software development. And by good fortune and blessing, then I was promoted quite rapidly from engineer to senior engineer, then to a team lead. And then after that, it was also by the gratitude of A-Star that I managed to lead a team to do software development. And then until a point in time whereby I felt that maybe before I become very old, I'm quite old now, but before I become very, very old, I should do something that I always wanted, which is to set up a company, a tech company. Because it always been my dream to start a company. So then I took the leap of faith and then started Augmentus with 2 founders. And then here I am today, sharing with you my life story.
So perhaps you'll say that maybe it's thanks to A-Star that you can have enough expertise to start your own company.
Yes. I have enough expertise, exposure, and experience to start my own company. Yeah, it's also, I think one very important thing I learned in my life is that during the start of my career, I thought technical skill was everything. Eventually, I realized that technical skill accounts for 20%. The remaining is uh, maybe 30 to 50% is networking, is the people that you know. Yeah. So, I mean, so even after you graduate, you start your own career. Even before you graduate, it's very important that you network a little bit more. Know more people, talk to more people, build more relationships. Yeah. I wish I knew that much earlier. I wish. Yeah.
Thank you for your sharing.
Yeah, thank you.
And a bit of background, me and Adrian is one of the MLDA ambassador. So Adrian is also was the host of the previous MLDA Insider. So
Oh.
yes, and both of us had some internship experience in A Star this summer. So that was quite interesting when we saw you are from A Star as well.
Yeah, I mean, it's a pretty good place to learn and grow.
Agree.
Yeah, agree. Okay. So I don't think there's any more question.
Yeah. I don't think there's any more question. So I guess we can end early around 8:55. We will wait like 5 minutes if there's any more question. Do you agree
Okay.
with that?
Yeah, sure, no problem. I love to share.
Yeah, quite interesting actually.
my life story. Yeah. So then Nelson and Andrea, so you guys are in third year, right?
Yes.
Yeah.
And think Adrian can unmute. Okay. Yeah.
And any plans after graduation?
I mean, we have to clear our bond to work in Singapore for 3 years.
As in, I think the only clear plan that we know right now is that we're interested in robotics and
Robotics.
this kind of application. Like we know that we're not going, at least if everything goes right, then I don't think we're going to things like process engineering and power electronics and things like
Yeah.
that. Yeah.
Okay. Actually, I was a foreigner as well. Yeah, I was a Malaysian. So I think I understand the situation that you guys are in regarding the career prospect in Singapore after graduation. Yeah, but I think, uh, but nonetheless, uh, have faith. I think by the time you graduate, things should will be much better. Yeah, the economy will be much better.
Yes.
Yeah.
And yeah, and I think the AI and robotics area, I think is booming. As far as I know, back then, before I left, the ISTA was hiring a lot of robotics people. Yeah, and then but they couldn't find the enough people to fill in the vacancies, the positions. So I think you will play. Once you graduate, you will actually have a lot of job opportunities available for you.
There's one question. So the question is, do Augmentus offer internship?
Yeah, we do offer. Uh, we we do offer internships, part time, full time, and all this. So if you're interested, then we can carry your conversation offline.
Okay. Is there any other question?
It seems like the dengue is more serious than COVID. I think they are spraying a lot
Sorry?
of the I think nowadays the dengue is more serious. Seems to be more serious than COVID. There are a lot of repellents being sprayed very frequently every day. I think a lot of people have caught the dengue fever.
Mm.
I think I think right now Singapore is becoming an innovation hub whereby there are actually quite a lot of startups in Singapore, and then China is investing heavily into Singapore as an innovation hub. And we also do observe that a lot of people who went overseas to develop, right, they are coming back to Singapore. For example, from the Silicon Valley. So I think the future is bright for you guys in Singapore. Whereby Singapore become an innovation hub, then you become the Silicon Valley of Asia.
Yeah.
Like there are a lot of in Singapore there are a lot of incubators, accelerators, and then there are a lot of assistance from the government to help you kickstart uh, your startup, which I think is a very good initiative by the government. I think even if our startup journey, we have received a lot of assistance and support from the government, which I really think that is very good to grow the local ecosystem. Because at the end of the day, perhaps 5 to 10 years down the road, when the startup ecosystem, when the startup become mature, they become companies that can help to sustain the local economy in the long term. And then this company, they have loyalty and branding to Singapore, and they can help to actually boost the sustainability of Singapore itself.
Interesting.
Any of you thought about doing a startup?
Well, not yet, but maybe if there's any opportunity, then
If we
yeah.
can come up with a very bright idea, then we will. But as of now, not yet.
I mean, yeah, I mean, coming up with a good idea is tough.
Yes.
Yeah, it's quite tough. I think I think the AI has a lot of opportunities for innovation. Yeah. So even though a lot of people are doing it, but to do it well, it's difficult. And I say, if you do a AI startup, I think the chances of getting investors is slightly higher. Yeah, this is something that you can keep in mind next time.
What about robotics startup?
Robotic, unless, well, this is a bit sensitive, but we can take this offline. Robotics is okay. Investment is separated by region. So if you are in the Western Hemisphere, it might be a little bit easier. Yeah.
Right. Don't think there's any more question. So I think before we end, we can show our face so we can post this on MLDA LinkedIn if you don't mind.
Okay, sure.
Okay. So everyone,